Right, hello. Wow, I'm loud. I'm Julian. I'm a front-end developer. I live in Graz, Austria. I work remotely for this company called Rainforest. We develop a product for QA testing. It's kind of fun. I joined them back in February. It's like had a hell of a ride, and we're hiring at the moment actually. So, and we're almost completely remote. So if you're looking, check us out. Anyway, so in 1962, in the summer of 1962, there was a NASA program called Marina, the Marina Program, and the Marina 1 launched in July 1962, and it was amazing. It was an engineering miracle. Everybody at NASA was very excited, and 2 minutes after launch, the ground team noticed that the rocket didn't respond to any navigation signals. So, unfortunately, they had to destroy the rocket. And all of that because of a software bug in a punch card, a syntax error. One character off. It was the most expensive bug in history, probably. The rocket cost about $130 million to build. So that guy must have had a really bad day. Which brings me to the topic of my talk. Yeah, so writing software is really hard, and writing code that doesn't blow up in production is especially hard. Because let's face it, we're humans, we make mistakes, it's natural, right? So what do we do to prevent us from making mistakes? Things like reviewing code reviews, or in some languages we have type safety, we have QA processes and so on. But like one of the most fundamental things, ways of making sure that your code doesn't blow up in production is to unit test, and that's what I'm going to talk about today. So, who's done unit testing at work? Who's doing unit testing at work right now? Show of hands, please. That's more than I thought. Cool. Who has never shipped production code with a buggy? Who has never ever shipped buggy production code ever in their whole life? No? There you go. That's why you unit test, right? So, what are unit tests? Well, they verify that a piece of code works as intended. And here's an example. It's like a simple function that adds two integers together. And below that, there's an expectation that verifies whether the function works as the author intended. That's the basic gist of a unit test below there. Right. Why unit test? So there you go. It's really hard to never break anything, right? We all break things because, as I said, we're human, right? So yeah, there is a bit of a trade-off. It slows you down a little bit because you have to make a little bit of a time investment to write unit tests. But the benefits you get from that are immense. For example, your rocket won't blow up. Right. So before I got into regularly unit testing, I was kind of a bit turned off because the kind of testing domain seemed to kind of belong to this elite class of programmers that are very opinionated about things. Kind of like we are opinionated about things in JavaScript, like frameworks, like, oh, there's only like, this is the best framework, and this is the best tool, this is the tool you need to use, and so on. And in testing, there's like different approaches, and people are religious about, you have to use test-driven development, you have to use behavior-driven development. They're even really nitpicky about what a unit test actually is, and so on. And that's really unhelpful, and it doesn't help people, it doesn't help make testing mainstream. It doesn't help getting people into this sort of thing, when actually unit testing is super simple. So I'm going to do a little coding exercise. And what we're going to do is we're going to fix the Marina. So, right. I've inherited this code from another engineer, and he obviously screwed it up, right? Like, we saw what happened in 1962. And as you can see in this simulation, the rocket launches fine, but right, when I press the left button, it goes right. When I press this, it doesn't do anything. The navigation controls are not working, right? We need to fix it. So instead of actually looking at the implementation and working out what's wrong, I'm going to take a different approach. I'm going to use unit tests to like clarify what this interface is supposed to do. So I'll just might as well tell you what I'm using here. Like, I'm using jQuery here because, well, I use React at work. I would never really use jQuery at work, but jQuery, everybody's familiar with jQuery, so using React or Angular in this case would have been a bit distracting, so I thought I might as well use good old jQuery. And here I have, oh, and I use, as you might have noticed, I use ES6 here, the ES6 module syntax, and I import a rocket control object, which is the control mechanism for our rockets, and a method that renders the rocket interface, which is this part, the launch button and the left and right arrow. And now I'm going to specify what my interface, my rocket interface, does. So, right, I've got the launch button, and this is its syntax. For those of you that aren't familiar with it, it's very common in JavaScript unit testing frameworks. It basically, in it, you describe the behavior of something that you want to test. So I'm going to write it out in plain English. Right. It should launch the rocket when the launch button is pressed. And I'm going to do the whole thing. It should steer the rocket to the right when the steer right button is pressed. It should steer the rocket to the left when the steer left button is pressed. So there you go. Here I've kind of specified what the rocket's interface should do. in plain English. And that's like the first major benefit, like one major benefit of unit testing is documentation. If I look at something that my colleague wrote, a module that my colleague wrote, so I just look at the tests and I see, oh, that's how it's supposed to behave. Right, now I can go in there and just do stuff because I know how it works. Right, so another major benefit of unit tests are that they are automated. So what I'm going to do is I'm going to run my test runner, and it's going to tell me, it's going to list all the unit tests that are in there. As you see, there's 0 passing, 3 pending, which means that at the moment we have 3 unit tests that aren't actually asserting anything, aren't actually testing anything. So I'm going to write the first one. Right, so I need to render the rocket interface. And then I'm going to simulate a click on the launch button. So what I want to test in here is when the launch button is clicked, is the right method called, the method that launches the rocket. Right. So I'm going to find the launch rocket button and trigger a click event. And now, to find out whether the right method has been called, I use a spy. So this all makes more sense when I write it out. I'm going to spy on the launch rocket method of the rocket control object, which is the method that launches the rocket. And now I'm going to write out an expectation that makes sure, that verifies whether this method has actually been called. So the spy is a way of figuring out whether this method has been called. It's like a fake function that you use to kind of track whether a particular method has been called. That's how it's used. And now, let's see what this does. Right. So this works. One passing test we have here, because the launch button is okay. Joe from the rocket engineering department didn't bugger that one up, which is great. Okay. Right, so I'm going to write out the actual, the other tests as well. And this is also a thing about unit testing. It's super trivial code. A lot of the time, you'll just copy and paste stuff because you want to test certain behavior, like has a certain thing happened if a button has been clicked, and so on. So once you get into unit testing, you'll find that it's really like you churn out a lot of code very quickly. Right, so I want to see if the steer right method is called when I click the steer right button. And no, it was not called. We have a failing test, right? So let's copy that again. And there you go, the same thing for the steer left button. Now we have 2 failing specs. And now, this is actually something I do every now and then. I just write these unit tests and the implementation without actually testing it out on the interface, which kind of you can cut out. That way you can cut out like a major part of your workflow, and at the same time write some unit tests. So it's like profit. Okay. Right. So let's have a look at the implementation. Time to look at the implementation. So Joe has obviously made some major mistakes here, otherwise this would be working, right? Can anybody see a mistake? Right. Okay, let's see if that fixed it. No. Still not working. What else? Brackets, yeah. There you go. Now we have two passing specs. That's awesome. And we haven't actually used the simulation. Now we need to look at the other one. Right, what's wrong there? Oh, right. So, does that work? Yes, it does. We have 3 passing specs. There you go. Let's see if it works for real. It does like kind of a disco move, which isn't amazing, but it works, right? So we can launch this into space. Right. So now the thing is, this implementation is more or less safe now, because when Joe comes back, and he will, because why shouldn't he? Like, he's my colleague, you know, I like him, he's a good guy. He should be able to like go into this code and refactor it if he thinks it's a good idea. So Joe is coming along, and he's like, what? This isn't modular. This needs to be more composable. Let's factor out this launch button here. And then we can render it wherever we like. Render launch button. Yes. Oop. So there you go, my old school jQuery skills. This could all be, oh well. Right. So now Joe's like, hey, but the event should be coupled with that components. So there you go. We've got this thing now. And Joe's like, oh yeah, and we also need to add this thing. The, what is it? Render launch button components. Right. There you go, Joe. But hey, something went wrong. Huh. Can anybody see what went wrong? Did somebody say something? No? What could have gone wrong here? We've got the event, right? We've got the template. What doesn't exist? Well, no, it does. You can see the button here, right? Look, this is the button. Well, but we are like binding the event to that element. We do the same thing down here. There you go. It's the wrong selector. And the thing is, these sort of mistakes are like really easy to miss, right? And that sort of stuff gets pushed into production a lot. Like, did anybody see the LinkedIn screw up where they rendered data in HTML, like it looked like a JSON string or something like that? It was kind of funny with all the like metadata and so on. LinkedIn, I mean, they should unit test, right? Okay, so this is all cool, but like, what if Joe actually is super naughty and has doesn't have his test runner running and wants to commit this bug into production, right? Or he wants to just push it to his branch, right? So he's like, yeah, I fixed my stuff, and I even improved his code, and then he goes and pushes the thing, and he waits, and damn, right? There's a git hook preventing him from pushing. So that's like, for anybody who doesn't know what a git hook is, basically you can run a script when you make a certain git command, like git push or git pull or git commit or whatever, and that way you can basically prevent yourself from making stupid mistakes, like pushing to master. There's other ways as well to do this. So let's make this spec work again. There it is. Right, it works. And now I'll push it into production. And, well, I push it to my branch first. And who has heard of continuous deployment, continuous integration? Right. So continuous integration is basically, or continuous deployment, whatever you want to call it, is basically a way of deploying code into production only when your tests pass. And that's super useful because, so at Rainforest, what we do is we push several times every day. And we couldn't do this without continuous deployment. So I have a pull request here. And the way this looks like is I can't merge the pull request into master until my tests pass. So my tests get run on this service. Travis CI is one of these services. So my tests get run in this service, and if they pass, then I'm allowed to merge. If they don't pass, I'm not allowed to merge. I need to fix my stuff. And that's like super, super valuable when you, especially when you're in a team of people who work with each other every day, refactor code, and so on. You want to make sure that you don't break things, because you might lose $130 million, right? So, unit tests, to reiterate, they're documentation, which is great, because I can go into my colleagues' code or look at an open source project, and very often open source projects have crappy documentation, but they have tests, right? So you can look at the tests to see what the thing actually does. And they also encourage you to write better code. So if I write code, I always have in the back of my mind, like, how would I test this? Is this easy to test? Easy code that's easy to test is usually good code, because it has to be easy to test. It has to be easy to understand. It has to be modular. Yeah. So the other thing is it gives you confidence. So it gives you confidence in your code. Like we said, like we can push things into production without worrying that we're going to lose 130 million bucks, right? It gives you confidence to refactor your code later on, even though you haven't touched it in like years, say. You want to refactor your code, and you can still make sure that all your things work, that all parts of your applications work, even though you haven't thought about your application in years. It's confidence to work on other people's code and for other people to work with your code. And it's about moving fast and shipping things constantly. And also, of course, we can't forget about the users who want to enjoy using your product and trust you as a company or a developer or whatever it is you do, right? So when do you test? When do you not test? Well, I think one simple way of answering this question is, do you care if it breaks? Like, if it's something trivial that you hack together for yourself, then it probably doesn't matter, right? If it's something that hundreds of users rely on, depend on, probably kind of matters, right? LinkedIn. Yeah, so it really depends, but most of the time, I think, especially nowadays, that JavaScript has kind of matured into this application development language, and we build more and more complex stuff with it, and it becomes ever more relevant to test your stuff, to make sure it doesn't break. Right. So, thank you, guys. It's also awesome, and it's been nice to be here. Do you have any questions? Oh yeah, and by the way, if you have any questions about testing or anything, if I can help you, just get in touch.
Hi. You're talking a lot about the confidence unit tests are giving you.
Right.
How do you, when you're writing tests, how can you be sure those tests are accurate, those tests are covering all the possibilities? And how do you know you're not gaining a false confidence in the quality of your code?
Right. So it comes back to that question, I think, of what do you not want to break? So I know that, like, as a user, if I press that button, I want the rocket to launch, right? Now, that's like also another way of answering this question is, like in my experience, like little coverage or few tests are better than none. So even sometimes bad tests are better than none. Because if you have no tests, you have no idea of whether you affected a different part of your code base, right? So that's kind of my experience. I've done like a big refactor of the rainforest front end 3 months ago, and it was basically this mess with global variables all over the place, and I had to take like, what is it, like 800 files and make it into common JS modules, remove circular references and so on. And that stuff can easily go wrong. But the thing that really saved me there was unit tests, even though some of them were badly written.
When you have somewhat like full coverage, you're gaining, in my opinion, you're gaining false confidence in your code, and you're thinking like, I've got it all tested, I've got 100% coverage, I can do almost anything. At least when it's green, it's okay. And in most cases, this is not really true.
It's a good point. Like, I mean, I think anybody who does tests is aware of the fact that code will still break. Like, it's not a magic bullet. It's like, well. But the thing is, it's much better than having no tests at all. I'm not like somebody who advocates 100% test coverage. To be honest, I don't even know what that means. Like 100% test coverage, that's kind of bullshit, right? Like you'd need to kind of be aware of every logic path of your application, which that sounds like a huge distraction. So it's really what makes sense? What do you not want to break, right? That's what you want to test, I think.